So in this problem, we're going to take a look at how to calculate the vapor pressure of a solution. And out here, we actually have a solution which contains ethylene glycol, which is the solute. Now this is actually CH2OH, and there's another OH out here. So I'm just going to write that out properly. That's a 2, and that's another 2, and then this OH out here should be OH. So that whole thing is the formula for ethylene glycol. All right. And this ethylene glycol is dissolved in water. So you have a solution of ethylene glycol in water. Now, in this type of problem, the ethylene glycol does not have a vapor pressure of itself. So this is called a non-volatile solute. Okay, I'm going to write that down. Non-volatile solute. And what that means is any contribution from the solute is negligible. Okay, so therefore we're only going to consider the vapor pressure of pure water, and then what vapor pressure, how that changes when you actually are looking at a solution with the water and the ethylene glycol. All right, so for this problem, we need to be aware of Raoult's law, and Raoult's law states that the basically based on Raoult's law, what we get is that the vapor pressure of the solution, let's call that P solution, is equal to the mole fraction, so that's X or chi, whatever you want to call it, the mole fraction of water, which is the solvent, times the vapor pressure of pure water. So let's call that P naught water. All right, so the vapor pressure of pure water out here, that's actually given to us. So that is the vapor pressure of pure water. So we already know that. The challenge is, how do you find the vapor pressure of this? So not the vapor pressure, sorry, the mole fraction. How do you find the mole fraction of water? So to find the mole fraction of water, we need to understand what the definition of mole fraction is. So we're going to write mole fraction of water is equal to moles of water divided by moles of water plus moles of solute, which is in this case is the ethylene glycol. All right, so maybe I should write that a little bigger, but maybe I can zoom in out here so you can kind of look at it carefully. So moles of water over moles of water plus moles of solute, and this entire thing, let's put that in parentheses out there. All right, so now that we know that, the first step is we need to calculate the moles of water, and then we need to calculate the moles of solute, which is your ethylene glycol. Let's represent ethylene glycol as Eg. Let's call that Eg. All right, so the moles of water is equal to the mass of water, which is given to us in the problem, 285.2 grams. There it is. Okay, and you have to divide that by the molar mass of water, which is 18.02 grams, and that's going to give us, if we divide that, that's going to give us 15.8268, and it goes on, moles. Okay, so that's the moles of water. Let's do the same for ethylene glycol. Remember, we call it Eg. So moles of ethylene glycol is given by the mass of ethylene glycol given in the problem, divided by the way, that's the mass, that's divided by the molar mass of ethylene glycol, which is 62.07 grams per mole. I forgot to put per mole out here on the top. And when we simplify that, we get 0.89092 and goes on, moles. All right, so now we have everything we need to plug it into this formula to calculate the mole fraction of water. So let's go ahead and do that. So the mole fraction of water is equal to moles of water, which is 15.8268 moles, divided by the moles of water plus the moles of ethylene glycol, which is again 15.8268 plus 0.89092. Let's put that in parentheses, moles. All right, so if we simplify all of this, we'll get 0.9467 and goes on. All right, so that is the mole fraction. So at this point in time, we have everything we need to kind of plug into this formula out here. So we know that, we figured out that. Now we just have to multiply the two together. So P solution is equal to 0.9467 times 23.8 torr. And that gives us an answer of 22.5 torr. Again, watch out for significant figures. We rounded to 3 significant figures because the problem gave us 3 significant figures for ethylene glycol, and 23.8, that's another 3 significant figures for torr. So essentially we're limiting our answer to the least number of significant figures because of what's given to us in the problem. And there you have it. So that's the answer to this problem. I hope that made sense. Thank you for watching.